To my channel. I am Dr. K.P. Naidu. In this lecture, I am going to discuss about the next category of supervised machine learning algorithm is linear regression. So the first point is linear regression is a type of supervised machine learning. That means to build a model using linear regression, the dataset must be a labeled data. And the second one is it is used to solve regression problems. And the next one is the linear regression is a statistical method for modeling the relationship between a dependent variable is also called as a target variable or output variable and one or more independent variable. These independent variables were also called as a features or predictors. That means by using linear regression, we are finding the relationship between dependent variable or that is called as some target variable and some independent variable. Clear? So the independent variable may be a single independent variable or one or more independent variables. If the independent variable is a single independent variable, then we are applying the linear regression. If the independent variables are more than one, then we are applying the multiple linear regression algorithm. Okay, we are try to clearly understand what is meant by target variable and what is meant by independent variable. Let us take the scenario in a particular company. I think that company spend some amount for advertising expenses, and based on advertising expenses that give some results in sales, for example over 5 months. So advertising expenses are this column. This is the one feature. This feature is where this is called as a feature. This is also called as independent feature. Okay, so this is also called as an attribute. This sales is depend upon the number of sales depend upon the advertising expenses. That's why this sales is called as a dependent feature. Is it called dependent feature or dependent variable, or it is also called as some target variable or also called as some output variable. Okay, so sales is a dependent variable or output variable, a target variable. Advertising expense is a independent variable, or these are some of the features or some predictor. Okay, this is about simple linear regression. Here we are having single independent feature. That's why to this data set we are applying the simple linear regression. For example, if the data set contains more than one independent feature, let us take the data set called as house price prediction data set. If you want to predict the price of a house, the to predict the price of a house, it may depends upon the some of the features called as area of the house, number of bedrooms, bathrooms, guest room, basement, hot water heating, air conditioning, parking. Okay, the price of the house depend upon these features. That's why these features were called as independent features or predictors. The price is we are called as a dependent feature or target variable, or it is a output variable. Clear? So in this case we are applying the multiple linear regression. First we are trying to understanding how simple linear regression works. The simple linear regression means it involves only one independent variable. That means in simple linear regression, we are trying to finding the best line, by taking the one independent variable x and one independent variable y. Clear? So as we know that in mathematics, So the equation to find that this best line or this straight line is actually y equals to mx plus c. Y equals to mx plus c. It is the equation to find the which one? Straight line. Okay. So this equation, if you are written as like this also. Here m is the slope, c is the intercept. Similar way we have to write to build a model using simple linear regression. We are writing this equation as y equal to beta naught plus beta 1 x plus some epsilon. Here the beta naught is a intercept. Okay, the beta 1 is some coefficient. Okay, epsilon is some error term that may be capturing the discrepancy between the observed and the predicted values. We may also neglecting this epsilon value also. Okay, it is not affecting the final value of the model. We are mainly focusing on beta naught plus beta 1 x. Whereas in the case of multiple linear regression, okay, the equation for model is y equals to. So in multiple linear regression, we are having more than one independent attributes or independent variables. For example, having x1, x2 and so on xn independent variable. That's why the equation for model is y equals to beta naught plus beta 1x plus beta 2x plus beta 3x3 and so on beta and xn plus epsilon. Here beta naught, beta 1, beta 2 and so on. Beta n are called as which one? Slopes. Are also called as which one? Coefficients. Whereas beta naught is the intercept, beta 1, beta 2 and so on beta n are coefficients are slopes. And x1, x2 and so on xn are what are called as independent variable are also called as predictor variables or explanatory variables. Y is a predicted variable are also called as dependent variable. Okay, that is the equations for simple linear regression and multiple linear regression. First, we are trying to understanding how to build a linear regression to the simple data set. Okay, so before building a linear regression model to the given data set, first the main objective of linear regression is we must need to find out the best fit line. We must need to find which one? Best fit line in case of simple linear regression. Whereas in multiple linear regression, we have to find the hyperplane. Okay, so if you are in case of multiple linear regression, we need to find the best hyperplane, whereas in the case of simple linear regression, we need to find the best fit line. Clear? So we have to find out the best fit line or hyperplane that minimize the error between the predicted values and actual values. Predicted values and actual values. How to minimize this error means the minimized error or the error we have to find out using the formula called as sum of the squared errors. It is also called as a cost function. It is also called which one? Cost function. Okay, as we know that what is the equation for error? So the difference between the actual value of the test instance or some given sample minus the predicted value of the sample is the difference between these two we are called as which one? Error. The difference between the actual value of the sample or instance and the predicted value of the instance is called as error. We have to square and finding the sum that gives the value of which one? SSE. So our ultimate goal is to find this best line. That best line gives the minimum error. So further by that goal, by focusing on that minimizing the error, we are trying to finding the which one? This best line. For example, to the given data set, for example, these are the points of the data set. We are finding this is the best line. Okay. So to this best line, if you want to find the error of this line means we need to find, okay, the difference between the actual value and the predicted value. Maybe the difference between this value and this exact value. Like this, the distance between these two gives the error. The distance between these two maybe give the error. The distance between these two maybe give the which one? Error. Likewise, we have to summation of all those errors. We are getting the total error. Okay, so we may getting different type of straight lines. For example, this is the one straight line. We may also, this may be also one straight line. We may also, this may also one straight line. This may also be one straight line. This may be also one straight line to these points. But once you are observing 1, 2, 3, 4, 5 straight lines. Out of those 5 straight lines, this straight lines covers all the data points, and this straight line, all these data points are nearer to this line. That's why this line may gives the minimum error compared to the remaining 4 lines. So our ultimate goal in linear regression is we have to find this best line. We have to find this best line. If we are finding this best line, obviously the error is minimized. Clear? So that is about the cost function to minimize the error in linear regression. Okay, so we are using the function is the function for linear regression is, okay, y I cap equal to beta naught plus beta 1 x1. What is the y cap here? The predicted value. So now we have to predict, okay, the value to the given instance or to the given value of xi. We have to predict the value of yi. So before calculating the predicted value to the given xi, we need to find the values of beta naught and beta 1.